Doctor. My name is Ying Jie, and I'm going to uh, discuss about my assignment one, video recorded assignment. So start with question one. Question one, we were asked to determine the magnitude of the resultant force and the direction measured counterclockwise from the positive u-axis. So to get the resultant force, we start with the resultant force plus to get our resultant force, we need to result the force F2, F1 to the axis X and Y. So we will draw a line. This is Y axis, and then this is the X axis. Okay. So firstly, we get the X axis one, the net force along X axis. So to get the net force along X axis, we resolve F2 to X. So to resolve F2 to X, we need to plus up this 30 plus 30, we get 60 degree. Okay. To resultant force to X, we use cos, and result force to Y, we use sine. So right now we are at the X axis, so we use cos. So F2 will result 60 degree, which we do like this: 150 cos 60 plus 200. This one is F2, we result 45 degree to X, so 200 cos 45. And then this is the answer for your x-axis, the net force at the x-axis. So next, we go to net force along axis Y. So let me do it first. Okay. So next, we do the axis Y. The same thing, we need to result F2 to your Y. So we will result both this addition, same, 60 degree. So right here, oh sorry, I written wrong. So this one is 60 degree. Okay. 150 result to Y, sine 60. And then F1 is 200 resultant to X 45. So 200 sine 45. But remember this one, your cos 1 is at the negative part lah of your Y. So you need to put your minus. So we minus this one. Okay. So after that you get this one. The net force along y-axis is negative 11.42. Okay, so next we will get the resultant by using this fixed formula. So after we using this formula, we'll get 216.7 Newton for our resultant force. Okay, so that's all for our resultant force. Next, we are going to find the direction measured counterclockwise from the positive u-axis. The same one, we are going to use this fixed equation. Okay, so tangent, negative tangent, and then I mean negative 1 tangent, negative 1 power tangent, and then a bracket Fy over Fx. So after that, you will get this one. Firstly, the degree gap is actually clockwise lah, so we need to do ourselves by adding a negative. So negative times negative, we get positive. So this is the counterclockwise of the degree of the counterclockwise. So we are going to stop at here for question one, and next we are going to question two. Okay, so next we are going to question two, and then right here we need to consider the IJK, which means that the direction for the XYZ. So F1 is here, and then it can go to Z, so Y, and X, so we will get this one. And then by doing this, we can get your F2 negative 120J, and F4 is negative 300K. Okay, because you see, your F4 is only go to the Z, and then your F2 is go to the Y. And just your F1 right here, is 160, you can like go to here, also here, and also to your z lah, like z, y, and x right here. You can move to here. Okay. So after that, you will use this equation to find your. We will write down this F3 equation with this, and then we can find P by using this one. And after that, we can consider the component, which is your axis y, axis x, axis y, and axis z by using the resultant thing. Okay, so your x, you will get this one, y, you will get this one, and then your z, you will get this one. So after that, we will use back the equation, which is this one. Okay, and then we will sub everything inside, and then we'll get P by using the completing square. Okay, so that due to F3 is obtained, so we are going to choose this one as our F3. So finally, you will get Fz equals to this one, and then the direction, you will use the formula and then sub in the thing, so you can get your F direction for alpha, beta, and gamma. Okay, so now we are at question 3. So in question 3, we are asked to determine the angle where 0 smaller or equals to theta and smaller or equal to 90 at point A. Okay, so we are given that our force is 4 kilonewton and our MA will be negative 10. Yeah, the force at your A is 10 kilonewton, but it is at the downside, so we will use negative 10. So taking the moment about A, we will do like this. We will sub the formula like this, and then do the calculation by moving here and there, and then after that we will get the answer, the equation of this one. Okay. So after we get the equation until here, you can I mean here, then we can throw our sign to the back side. So here becomes sine 0.7309, 0.7309. Oh, sorry, I mean the sine power -1 power 0.730. Then you will get this one, and then the backwards one also sine, and then sine power -1 0.89902, and then you will get this. So your final answer for your angle at the moment at point A will be 46.96 degree and 64.03 degree. So here is question 3, and next we are going to question 4. Okay, here we go to the the question 4. So question 4, you need to write all of these to your image, then you can start to do. So first we do this one. We check with the horizontal direction. Okay, so in horizontal direction, you will see that you have a resultant force to here, which is positive, and then the opposite will written as negative. So your formula will be this one, and then after you use your math method, and then you will get your force equals to 5.2 kilometer. Okay, next we check with the m. Okay, when m equals to 0, then we will find NA. So here we got NA, and then uh, your this one, and then the resultant. So after that, you get everything written as a formula. You will find out your n, A equals to 73 kN. And then last will be your third. You will consider the vertical part, which is Fy equals to 0. So right here, the vertical one, you will get positive Na. So we write here, and then negative, because this one is the opposite, correct or not? So we consider here positive, then here will be negative. So this one done, this one right in, and then your resultant force also to downside, so it's negative, and then plus your NB equals to 0. After that, you will use your mathematic method lah. So you put here and there, like making all the things to behind and then left and B in front, you will get 24.9 kilometers for your NB. So here you will get NA, NB, and your force for this question. Awesome. So right here is question 5. Let me see. We are asked to determine the greatest force P that can be applied to the truss so that none of the members are subjected to a force exceeding either 4 kN in tension or 3 kN in comparison. So we can separate these to joint A, F, E, and B and C. So first we see the joint A. A is right here, and then we will draw the axis diagram at here. So right here we can get F. That is, we are forced to here, and then forced to here. So here we need to use the resultant thing lah. For Fy, which is vertical component, we will result FAF to here, which is 45 degree, minus your P, because you see, if you result here will be positive, and here will be negative, equals to 0. And then after that, you will use the formula, and then you can get this one. Okay, done. We will check with the y-axis. So if y-axis component is 0, we will result this thing. Okay, so FA will be this one. We get the F, the force, here, cos 45. Okay, and then minus your FAB. FAB will be like here. So here is positive, here is negative. Okay, so after you get this one, you get FAB equals to PC. I mean P only. Okay. So after that, we see the joint F. join F will be right here, and then this is the diagram. So F, we have a force in this direction, and then this direction, and then here this direction, so we get this one. Okay, also we consider the Fy x-axis, I mean y-axis. You will resolve your FFB cos with 45 to here, to here, and then your this one FAF we know is this one correct here. Okay, then we cos to here. After cos to here, you will get this 0 because this is the component y. So after that, you will get FFB equals to 1.1 1.4142p. Okay, so this one is tension now. And then after that, we will get sorry, this one is not trust is not yeah, it's tension, sorry. So this one is tension, this one is compression. Okay, because this one is not exceed 4 kilonewton. So if this one is tension, then another one will be compression. Come back to joint F. We continue to check with the Fx. So right here Fx, we will use the formula again. Result your F. FFE is already x-axis, so we just write it and we consider this one is positive. So this one, if we resultant to here, we will consider it as negative. So we result your FAF equals to 1.4142 P sine 45. And then another one, this one is at the negative part, so you result to here, you get this one. And then after that, you will get your final is this one. So this is your tension and this is your compression. Okay, next we see joint E. So joint E, we will put a X at here, and then we have the force to here, down. Yeah, these three force. Okay, so this one we will do the result. We will get the equation by checking your Fx. So this one FED minus 2p, you get 0. This one. So your FED equals to 2p. So 2p is tension. This one is tension. And then, so another one will be 0 because it's only right here, right? If there's only one force, then we no need to check with other thing lah. So this one is when y component is 0, so FEB equals to 0. Although it is like go to downwards should be negative, but no matter what is 0, like no matter negative or positive, 0 still 0. So this one is 0. So here we are not going to have either tension or compression. Okay. So next we see the joint B. Joint B. Joint B, we have force to here, to here, to here, to here, and to here. Oh, sorry, this one is this. Okay, so we will get this one, joint B. Okay, so when we consider Fy equals to 0, which is your y component, we will have resultant FBD sine 45, and then we get negative, where is it? FAB P sine 45, this one. Okay, after that, we will get FBT equals to 1.414 to P. So this one is tension, which means this one is tension. So the next one will be compression. So before we check, we need to find the magnitude of X. I mean the x-axis, the force in x-axis. So x-axis we have P. PAB we said is P. Okay, and then plus with the same direction. This one will result to here. F, we get this one. And then another one will also result to here. So we'll get this one. And then minus your FBC. After that, we will get this one by using the math method. And last, we are going to join C. So all of this, we need to consider the joint, the force, and then we can get the final answer. So this one is C. The next one is joint C. Joint C, we will have force up. And here the force comes up. And so this is your diagram of the axis, and then you will consider your x component. FBC equals to 3P, so 3P minus your MC, because this is the opposite direction. If you put this one positive, that one is negative, equals to 0, we will get NC equals 3P, so NC is compression. So due to there's only one force in your y, so if your Fy equals to 0, then this one your force CD will be 0 lah, so nothing will be here. So that's all for question 5, and then next we are going to question 6. Okay, so now we have come to our last question, which is question 6. Okay, so right here you need to draw out the free body diagram so that you can consider that. Okay, so at 0, smaller or equals to x or smaller than a, your free body diagram will be like this. And then we can consider the vertical component, and then you will get p equals to p. And then we check with the m, the momentum, so will be 0, and then your m will be px. Okay, so done for your 0 smaller or equals to x and smaller than a. Next, we are going to a smaller than x and smaller than l minus a. So right here, we need to consider the vertical component, and then we will get v equals to 0. And then the momentum, and here we will get m equals to pa. So you can get this by looking at the diagram. So like here we got negative px plus p bracket x minus a, and then plus m. So all of this can be get by the diagram. And then finally we will come for L minus A smaller than X and smaller equals to L, and we say we consider the vertical component at the end. So if vertical component equals to 0, we will get B equals to negative P. And then for M, if M equals to 0, we will get M equals to P bracket L minus X. So that's all from me. Thank you.